Hi guys, so today's notes are our last type of compounding that we're going to study in this unit, good interest, and that is continuous compounding. And it's an interesting concept because it brings in the idea of infinity. What if instead of annual compounding once per year, or quarterly compounding 4 times per year, or even monthly compounding 12 times per year, and we haven't talked about daily compounding, but that is a way that some financial institutions use compounding every day, 365 times per year. What if the compounding was so frequent that it was virtually constant? And we touched on this a little bit when we learned about the letter E in our spreadsheet. And recall that the number E, I should say, it's represented by a letter. Euler's number was approximately 2.718 in a non-repeating, non-terminating number of decimal places after the decimal, much like pi. And we derived the approximate value of E by taking 1 plus 1 divided by some number, n, and then we raised that value to the same n, that same number that we plugged in for n. And recall that the larger the n value became, the closer this value approached E. So you may recall from the video that there was a little concept called a limit, and they just briefly touched on that, but this is essentially calculus. The limit as n approaches infinity is how you would read that. So as n gets larger and larger and larger, when you divide 1 by that larger and larger number, then you're approaching a tiny, tiny number that you're then adding to 1. So it's really not much bigger than 1, but then you raise it to a huge power. And interestingly, you get a graph that looks like that. And this value right here on the y-axis is E, or 2.718 approximately. All right, what does that have to do with the price of tea in China? Well, what we're studying today is called continuous compounding. And much like we've studied in the past, what if we took that initial investment? So recall our compounding formulas from the past. We took that initial investment, we multiplied it by 1 plus the interest rate divided by the number of compounding periods to the number of compounding periods times t. It kind of looks like this guy up here. So what if that n value approached infinity? The number of compounding periods was more than 365 daily, was more than hourly, was more than minutely, was infinite number of times. Then all of this is going to boil down into the number E. And the formula becomes as simple as this. P sub 0, that's your initial investment, times E to the rate times time. And there it is. Principal times E to the rate times time. Let's do an example. Okay, here we go. We're going to invest $5,000 at 4.5% annual interest for 7 years, and that interest is compounded continuously. So the formula, recall, is the principal equals the ending principal equals the initial principal times E to the power of rate times time. Rate as a percentage, time in years. So it's really quite simple. P sub 0 is the initial investment, 5,000. E is the number E, 2.718 approximately. The rate is 0.045 4.5%. And I'm going to use parentheses to show multiplication, times 7. And that's it. Now the kicker will be, can you enter that into calculator appropriately? And during class tomorrow, I will be showing you how to do that with phone calculators and Desmos and other applications. I'll be right back with the answer. Sit tight. So I used Desmos to enter this into the graphing calculator as written, and I got approximately $6,851.29. Remember, we don't round that cents digit. Okay, that's how we do it. Simple formula. Make sure you know how to put this into the calculator. We'll go over that today, and that is continuous compounding. Sorry guys, I forgot to tell you that the practice sheet that I'm giving you with these notes uses a little bit different notation for the formulas. So the amount of the loan they call A for amount, and P they just call the principal, they just call P instead of P sub 0. So it's the same formula. You can see over here for simple interest. I don't know why that's defaulting to yellow, but there you have it. I said simple interest, but I meant continuous compounding. So the amount in the account at the end of the investment is the principal times E to the RT. Same thing, just a little bit different notation. Okay, good luck.